All right, welcome to our video here on the fundamental theorem of calculus. This is a very, very important video that you do need to understand because this will go further down the road. This is like really what our foundation is for a lot of the calculus stuff, for the antiderivative stuff, and we keep building and building on it, especially when we get to word problems. This is extremely important to understand. So, well, what is it? What's the fundamental theorem of calculus? Well, suppose f is continuous on a to b. Then, if we integrate from a to b of the derivative, it's the same thing as the original of b minus the original of a. There's a couple different notations for it as well. This is one notation. I'm going to probably show you all the different notations as we go through the problems, but pretty much all I was trying to say is the antiderivative of the function, if you plug in the top bound minus the antiderivative function, plug in the bottom bound, that's what it's equaling for that point right there. Okay, so this is really equal to this right there. The reason that this does get so important is for this to be applicable, this is finding the area underneath the curve from A to B. That's what this is. This is finding area. Under a curve. Or area under a function, really. Okay, so let's go ahead and get to it. So for this first example right here, we need to find the antiderivative of x squared and 3. So the antiderivative of x squared is going to be 1/3 x cubed. Antiderivative of 3 is 3x. I'm going to evaluate that, put the little brackets around here, from 2 to 1. So this is going to be 1/3 times 2 cubed, because I'm plugging in the 2 right now, plus 3 times 2, minus, now I'm going to do the same thing but plug in a 1. 1/3 times 1 cubed plus 3 times 1. Okay? And then you're going to evaluate each of those. Sorry, this looks a little blurry. Let me see if this makes it look better. Probably not. Probably the same thing. So I can go ahead and do all this math. Let's use my cheat sheet because I don't want to waste your time here with just simple arithmetic. So this is going to give me an answer of 16/3, but you would have to go through and figure that out yourself. Okay? So what this is trying to say, let me just kind of draw a picture here, is here's an axis, and this function looks something like this, give or take. And I'm trying to find the area from 1 to 2. So this area from there to there. So what I just shaded in purple is going to be 16/3. That's what this is representing. Okay. So look at our next example here. We got x minus 4 all over root x. The problem is I can't take the integral of this. There's no antiderivative formula for this. So the easiest thing to do here is to go ahead and chop this up and separate it. So this is from 1 to 9 of x over x to the 1/2 minus 4 over x to the 1/2. Now I'm just one step away from simplifying it so that I can work with this now. So this is going to be the integral from 1 to 9 of x to the 1/2 minus 4x to the negative 1/2 dx. Now this is not so bad. So again, we're going to add x to the 3/2. So we're going to divide by 3/2, which becomes 2/3. Minus, this is going to become 4 times, I'm going to leave a space there, x to the 1/2. And then we're going to divide by 1/2, which is the same thing as multiplying it by 2. Okay? And then I'm going to evaluate this from 1 to 9. All right? You don't need an x equals up here at all. You can just put the 1 to 9, and then you're totally good. I just want to double check some of my work here. Just make sure. Okay. Because again, I don't want to waste your time with the arithmetic. So if we plug in a 9, we're going to get 2/3 times 9 to the 3/2, which you do need to know that that's actually the square root of 9 to the 3rd power, minus, that's going to give me 8 times 9 to the 1/2, which is the square root of 9, minus 2/3 times 1 to the 3 halves. Well, 1 to any power is going to be 1 minus 8 times 1 to the 1/2. Again, I don't want to waste your time here, but you would do this arithmetic and you should get 4/3. Okay? Let's go to the next one, secant squared, dx. So what's really nice about this is there is a formula for this. There is a direct antiderivative for that. Do you happen to know what that is? It's tangent. So this is really equal to tangent. And here's the difference. You can also do it this way with just one line, from pi over 4 to 0. So if you just look at the different notations, it doesn't matter. If I wrap it all up, that's fine, from 2 to 1, or I can just put a line next to it. The reason that I wrap it up is whenever I have like multiple terms, I like to just wrap it up so it's pretty clear what's going on. If I just have the one term, I usually don't wrap it all up. I just put the big line right there. So we're going to go tangent. So tangent of pi over 4 minus tangent of 0. It's really nice to know what these numbers are. You should get a 1 right here because you're going to get tangent of pi over 4 is 1 minus tangent of 0 is 0, which is going to give us a big old 1. Okay? Next example. Now, there's a previous video that I mentioned that if you could ever use geometry, use geometry. And this is actually going to be a case right here. Okay? Because in order to take this antiderivative, I need to actually break this up because this is two different curves. Remember, an absolute value is like a piecewise function. So there's two different curves for an absolute value. So what I'm going to do here is I'm actually going to sketch this out real quick. So here's 0, here's 1, 2, 3. Okay, so if I'm at 0, I'm at a height of 1. Sketch it in blue here. And then if I set this equal to 0 for the x-intercept, I'm actually going to get 1/2. Okay, if I plug in a 1, I'm at 1. If I plug in a 2, I'm at a 4. No, 3. Plug in a 2, it's 3. Which is right up here. This is definitely not going to beat to scale. And if I plug in a 3, I'm going to go all the way up to 5. 1, 2, 3, 4, 5. Okay, I know that's not straight. I'm just sketching it. Okay, so I really just want to find the area of this figure right here. Two ways to do it. You could go ahead and split this up into different integrals from 0 to 1/2 and then from 1/2 to 3. Totally do that, or we could just use geometry. So if I were to use geometry here, I just want to use my cheat sheet, make sure I don't get anything wrong, because I would not like that. Okay, so for the first figure right here that's shaded, that formula is going to be 1/2 times base times height. So the base is 1/2 and the height is 1. So this is going to give me 1/4. And then for the bigger, I'll show this one in purple. That's going to be 1/2. The base is actually 1/2, 1.5. It's actually 2.5. So that's 5 halves. And then the height is 1, 2, 3, 4, 5, which is going to give me 25/4. So all I'm going to do is just add these together. Yeah, got it. Add these two bad boys together to get my total area, which is going to give me 1/4 plus 25/4, which is 13 halves. So again, I think it's easy to use geometry when possible. It's a lot less work. You got to do some counting and some old school geometry. Moving on. All right. So here is another absolute value problem. So I think it's easiest to sketch this. In this one, unfortunately, we cannot use geometry because this is not just a straight line. This is curves. And you might look at it and go, oh, that's a circle. Not necessarily. So let's go ahead and sketch this. So by the way, x squared minus 4 is just a curve. I'm going to kind of just mirror it like this. Okay, just a curve that looks like this, except I can't go below this axis right here. So 1, 2, 1, 2. I do know that the x-intercept, if I plug in a 0, sorry, y-intercept, 1, 2, 3, 4, is right here. I do know that my other zeros are here. So I'm going to get this. Okay, and then this. All right, so I'm trying to go all from -1, which is here, all the way until 1, 2, 3, which is here. So if you notice here, I'm going to have two different functions. So this one I'm kind of handcuffed. I'm going to have to go through and to do two different functions here. So my first integral is going to be from -1 until 2 of this, okay? And this is the negative version of this. This is negative x squared minus 4. Because this is the part that would have been below the x-axis, but it's negated now because of the absolute value. Dx plus, now I'm going to go from 2 to 3 of now the positive version of this, x squared minus 4. Dx, I'll just wrap that up as well. Make it look nice and pretty. And this is my setup for this guy right here. Okay, so I'll let you go ahead and distribute everything on your own. I just kind of want to give you the quick answer part right here because, again, I don't want to make this video too long. So for this, I'm going to get -1/3 x cubed plus 4x. That's from 2 to -1 plus, this is going to go 1/3 x cubed. If you notice opposite signs, minus 4x. This is going to go from 2 to 3. And I'm just going to end up with an answer of, when it's all said and done, 34/3. Again, I don't want to make this video too long, so this is something that you can just work out on your own. Make sure that you do match the answer right there. Okay. Last problem, find the area bounded by the graph, and it gives me this graph right here of the x-axis. And in the vertical lines, x equals 0 and x equals 2. So what I'm going to do here is I'm going to do just a little bit of a sketch just to see what the heck this looks like. So if I plug in a 0, I'm going to get 1, 2. Now, you don't have to sketch it, but I will just so we can kind of imagine what's going on here. And then if I plug in a 1, that's going to give me a height of 1. And I plug in a 2, what is that going to give me? It's going to give me 8 minus 6 plus 2. So it's going to look, let me see where the vertex is real quick. Yeah, I think it's going to look something like this. Give or take. Vertex is going to be there at 3/4. Don't worry about that, though. So it's going to look like this. So I'm trying to find it from 1 to 2. So I'm really just trying to find this shaded blue area. Now, you do not need to split it up because this is actually just one function. You're just trying to find integral from 0 to 2 of this 2x squared minus 3x plus 2 dx. And that's it. You don't need to put this in parentheses, but I will just so it looks nice and pretty. And then you just kind of go from there. So the antiderivative is going to be 2/3 x cubed minus 3/2 x squared plus 2x. Evaluate that from 0 to 2. You're just going to plug everything in. All right, so you're going to get 2/3 times 2 cubed minus 3/2 times 2 squared plus 2 times 2 minus, what's super nice here is what's going to happen when I plug in the 0. 0 minus 0 plus 0. So I'm going to just put a big old 0 right there. Super nice. And again, I'm just going to just kind of save the math for you. We're going to end up getting 10/3. Yeah, I don't want to make this video too long. So make sure you do this arithmetic. Make sure you do match up with 10/3. You do need to practice it. You're not practicing the arithmetic you're going to have some problems. Okay, so, and that's it for fundamental theorem of calculus.